So this guy, Peter Hong, he shared the interesting little project that Stanford and Google did. And basically what they did was to create a simulated world where they gave a couple of different characters some basic backstory. They had some, let's see here. Yeah, they gave them a name, identity, an occupation, and some priorities. They gave them some information on the relationships to the other characters, and somehow like a mission. So the main character in the plot that they sort of built things around were supposed to throw a Valentine's Day party. And then another character who was in love with, let's say, some other guy named Larry or whatever. She had, like, okay, her goal was to, like, get him to notice her. So she volunteered to join in the preparations for this Valentine's party. And then they, started sending out invites, and basically based on these few commands, they started acting and preparing things in the game world. And I think this is pretty cool, I guess, from what I know from ChatGPT-3 is like it's like it's basically just a conversation model. So having an individual like reference point for each ChatGPT-3 and model, and then having them talk to each other. So this is, to me, really interesting in terms of like what gaming might become in the future. And I don't know. I just wanted to riff a little bit of what you think the utility of these models will be in gaming in the future.
Yeah.
Do you have some like interesting use case or something? I mean, I can think of a couple of different games that I would like to play that had this kind of these kind of features built into it.
Yeah, for sure. Everybody that's writing on Reddit is talking about how the next Elder Scrolls or whatever should be using these kinds of autonomous agent type technologies.
Mm-hmm.
I guess it's funny. Richard Feynman and others, when they were doing some of their most important work at Los Alamos, and others, when scientists that were developing Unix,
Mm-hmm.
when they were doing all these experiments, a lot of times they ended up starting off by playing games to do their science.
Mm-hmm.
So one of the first things that people did on a Unix system, first of all, they invented the C language in order to make Unix, and then they invented Unix in order to have an environment to program C in. So it was sort of like chicken egg type thing.
Mm-hmm.
And then the second thing they did was they programmed a Star Trek video game to
Mm-hmm.
play on the system. That was
Okay.
the first thing they did. There's so many examples of, and in the case of Richard Feynman, the computers they had back then weren't with screens and stuff. They were just like, they would poke dots in paper and you would have to read it. And really they were just for solving equations. But the scientists, the first thing they did was like, can we make these funny patterns? And they're like, look at my pattern, mine was cooler. And they're just playing around with it. So I think video games, probably even before computers, is always, or entertainment has always been a number one driver in why we do this stuff. So I feel like video games are central to everything. And the fact that NVIDIA is so connected with video games, it's maybe a coincidence, but it's not a coincidence.
Yeah, I think we had this conversation before sometime last year. It's basically what have driven the whole development of all these GPUs, why they're so efficient, because gamers were willing to pay for better hardware.
Yeah.
And now we can do all these super awesome, like large language models trained on like one strong GPU. So this is going to be a driver once again, I think, the entertainment industry. And that's I have some notes here on what like Hollywood is saying about all their like IP questions and so on, but we can go in a little bit more.
Yeah, let's focus on the games for one second again, because there's something neat about games in particular, which is that they're a good sort of testing ground for lots of other things. There's two ways we can talk about this particular example of the agents preparing the Valentine's Day party and whatnot. There's the technical elements,
Mm-hmm.
i.e., exactly what is it we discovered, why is this research relevant, sort of what technical breakthroughs allowed this to happen and stuff. And then there's also the how does this fit into society and use cases and other stuff.
Mm-hmm.
And there are some pretty fun outcomes. You can actually go online and replay what happened and look at each individual conversation, and
Yeah.
they're pretty funny because this person or this agent planned the Valentine's Day party and 12 people found out about it, but only 4 people showed up. 3 people were too busy, and
Mm-hmm.
4 people, like in real life, there's lots of fun things about human psychology to learn from this. And in fact, they analyzed it afterwards and asked people to role play some of the roles.
Mm-hmm.
And according to others who then reviewed what the agents wrote and what the people wrote when they were role playing,
Mm-hmm.
their observation was that the agents were much better at role playing than the people. Obviously, we
Yeah.
have people that are very good at role playing. They're called actors,
Yeah. Yeah.
right? So it's sort of funny to think that these agents are fairly good actors. Presumably, they've studied,
Mm-hmm.
something role playing like. But the cool technical stuff in this in particular is twofold, I'd say.
Mm-hmm.
There are two big directions, big research directions that a lot of people are excited about now. One
Mm-hmm.
is multimodal models,
Yeah.
and the other is stuff that has to do with uh, models being able to remember and think more about what they're doing.
Mm-hmm.
So the first thing about multimodal models is essentially if you have a language model that has an understanding of the stuff that it's talking about based on having studied text about it,
Mm-hmm.
you can give it a better understanding by also letting it study images. And obviously, text and images are very ready at hand. We understand what that means, but really, multimodal models means everything else. So the most cutting edge examples of that are robots that are embodied.
Mm-hmm.
If you give it both input of where the arm position is in space and a picture of an apple and a description of an apple, and you give it like 5 different ways to understand the concept of apple in terms of how much space it takes in real life,
Mm-hmm.
and a description of how many cubic centimeters of apple it is,
Mm-hmm.
and a picture of it, and blah 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 blah.
Mm-hmm.
That makes it a ton more robust. This is the logical extension of what
Yeah.
some of us have known for a long time, which was the early language models that were good at translating from English to Spanish
Mm.
got better at translating from English to Spanish if they were allowed to study German.
Mm.
Obviously, because you have a better understanding of language and intent and all that kind of stuff. These things sort of are part of
You're
the
looking at
same
from
model.
more sides.
Exactly.
Basically.
So obviously, multimodal models means giving the AI more opportunity to look at the same thing from different angles. So that's one research direction.
Mm-hmm.
The second research direction is large language models, and this is something that's really confusing even to senior AI implementers, let's
Mm-hmm.
say. Um, Large language models right now generate their output one word at a time.
Mm-hmm.
So by forcing the model to generate one word at a time, it really commits to stuff. For example, if you ask a large language model to count how many prime numbers there are between 0 and 100, it needs to start talking one word at a time. And it has 96 layers of complexity, let's say.
Okay.
It has this thing called a attention matrix inside.
Mm-hmm.
And every jump from one attention matrix to the next lets it sort of do some meta reasoning.
Yeah.
But if the calculation that it's trying to do in its head is more complex than what fits in that one sort of pass through all the 96 layers,
Mm-hmm.
then the output's going to be a little bit dumb, or it's going to be wrong even.
Mm-hmm.
So if you ask it, for example, list how many prime numbers are there between 0 and 100, it's going to start saying there are, and then it's going to struggle and spit out something dumb. But
Mm-hmm.
if you instead say, list all the numbers between 0 and 100 that are prime and tell me how many you listed,
Mm-hmm.
it will be able to go and spit out number after number and then go back again and think about it one more time.
Mm.
And it will produce a correct answer.
Yeah.
So, and we've seen other examples of this where if we ask it to simply produce an answer, it'll produce a wrong answer. And if we ask it to explain its steps, it will get more opportunities to sort of look through what it's spitting out and then go through these matrices many, many times over and then produce a coherent output. So what people do is they mix up the fact that the models spit out one word at a time with that it's not really able to think about this stuff in many layers of reasoning. It is the serial output has nothing to do with
The reasoning.
with how powerful its reasoning capabilities are.
Yeah.
However, it does commit the model to how many times it's allowed to think about stuff. So if you say, tell me how many prime numbers are between 0 and 100 in 5 words or less, it's not going to be able to do that. Just like if I were to ask you that question and say you have 2 seconds to answer.
Yeah.
So that's the first thing. And one way we're trying to get around this is by giving the models an external database. It doesn't have to be a database, but a way to sort of let it think about stuff without outputting words.
Yeah.
It can you can use that for it to remember things or to think about what it's thinking about or whatever.
Yeah.
So basically, we're giving it memory. And that's what this experiment was supposed to do. If we have agents, chat agents that are able to read what other people are doing, look at their to-do list, and then act on that, what happens?
Yeah.
And so these agents are really 100% independent actors in this game, following their to-do list and trying to figure out the best way to do these things. And it's super cool. It works, and we see emergent phenomena, emergent cooperation, and other cool stuff.
Yeah. But in this case of multimodal, what was the exact word? Multimodal
Models.
Yeah, modal. Isn't that sort of like the big issue in terms of reliability? That's usually like the next step, that you need more than, let's say, just language to make something super reliable. And that's, from what I understand, the big challenge of like self-driving cars and all of these things. You need to combine super many data sets to have a reliable output.
Yeah. This is something that's hotly debated.
Yeah.
What's being debated is not actually what the case is, but rather what research direction will lead us to something that's more robust. And we have 5 different ways of achieving it, or 10 or whatever.
Yeah.
And the scientists don't necessarily agree which direction is most promising.
Yeah.
So we don't actually know, or I mean, if we knew exactly how to make the models 100% reliable in a way that we feel is reliable, then we would do that.
Yeah.
And there are many reasons why that's not clear. I think it's important to admit why it's not clear, because when people say they're not reliable, they say they're not reliable because, and we should do this to fix it. This is what we're debating. So consider this, for example. If we take the example of self-driving cars, humans obviously drive with their eyes only. We don't have LiDARs. And yet we're fairly reliable in terms of kilometers per accident. The first question is, are machines more reliable than the average human? And as it stands right now, it seems yes.
Yeah.
So it seems if we were to replace every human at once with machines, we would be better off. Now, there's another issue of, okay, who do we blame when something goes wrong? Who do we put in jail? Somebody needs to suffer. Otherwise, I'm not going to be happy if there's an accident and there's nobody to blame for it. And I feel like that's a completely different discussion than how do we get the machines to be robust. The second thing is, it seems to be, Tesla put a giant bet on being able to do everything with just cameras. And many people were really doubling down on how stupid Tesla was for doing this, as if they were more insightful than Andrej Karpathy and all these AI researchers. It seems that Tesla is doing quite well for itself with its self-driving betas. They are pretty damn good. So it's not clear what it is that leads to more reliability or not in that case. But I think it's easier to talk about reliability when it comes to large language models, because the only thing we say about self-driving cars is we talk about the long tail. What happens if you're in a driving scenario where there's something bright in the sky and an old lady runs across the road and there's a speed bump and two children in a trolley? Which direction do you swerve? Like, it's really hard to reason about what it would take to handle that situation correctly. But when it comes to language models, it's much more funny, because I spoke to a guy recently that said ChatGPT is a conservative shill. No, a liberal shill. And because I asked it about some contentious topics, and it gave me such liberal answers, which are not true. And then and here, that's the keyword, right?
Yeah.
What's true or what's not? Everybody's saying we need to make these more factual. What's a fact? These are philosophy questions. These aren't technical questions. And so if you look at the interview with Ilya Sutskever, when he's talking about alignment, the hard question of alignment is not only how do we train the models to be more aligned with us, but how do we even figure out what it is that we want and measure that?
Yeah, but I mean, like, we aren't. I mean, we're applying this idea that we need to align AI, but do we even apply? I mean, how can we align it with us if we ourselves are not aligned?
Sure.
I mean, that's one of the things. Like, are we even trying? How are we trying to align ourselves with each other today? I mean, like, I don't see much of that going on, let's say, on the lower levels of society. I mean, like, okay, so EU is talking about, like, how to align their, like, data initiatives or whatnot. But in terms of just regular people aligning themselves with each other, that's not really happening. And then there's going to be a lot of different AI technologies, and they're not going to be aligned with each other either. It's like, this is sort of it seems to me to be sort of a dead end.
Well, there are two big camps. On one camp, you have maybe the technologists, and there are AI ethicists that use very pejorative terms for this camp. But you have the technology people that always talk in terms of an objective function, i.e., what is our objective and how do we measure it? And then you have others that want to be sort of virtue ethicists. So, for example, there was a really nice paper last year called the AI Economist, where they used an AI to plan how taxes should be managed in a game, and the AI was quite good at it. Now, what happens if you have an objective, which is to lower the taxes as much as possible and raise the service levels as much as possible? And the AI does that, but it does it by doing something that goes counter to your dogma. And the question is do you have dogma for the sake of dogma, or do you have dogma for the sake of some objective? And I think everybody likes to pretend like they have this dogma of either capitalism or socialism or whatever it may be, because ultimately it will result in the greatest good. But then when you show empirically this is a way to reach the greatest good, no matter how you measure it, and it's not in alignment with your dogma, are you willing to change? No. And that's like religion to me.
Yeah, but I mean, there's I think,
and all the people that are asking like for the pause, the 6-month pause, in my view, are these dogma people that say we need to align ourselves with each other first. We haven't been able to do that for thousands of years. But 6 months, come on.
No. But dogma, as you see, like, it's a reference for a certain cultural group to be able to collaborate with each other. It's like, what kind of dogma do we have in society? What kind of values do we have? Okay, so we use dogma to be able to identify which team somebody else is playing for. That's sort of the utility of dogma. It's not the outcome, it's to identify the other players in the game, which is two completely different things.
I think, you're right. There's probably an element of using it as a quick sort of identifier for somebody's worldview. And then just in terms of game theory, okay, so in game theory, there's a very simple rule called tit for tat, which is what you do, I do back to you.
Yeah.
So if you're nice to me, I'm nice to you.
Yeah.
And if you hit me once, I hit you back once.
Yeah.
And that strategy, as simple as it sounds,
Mm.
works very well for for building balanced systems in game theory.
Yeah.
And that principle is very good to follow when you don't have perfect information about a system.
Mhm.
So, for example, if you have perfect information about a system, it might be good for you to lie. Because if you know
Mm.
that you can lie and get away with it, then that might be a smart tactic.
Yeah.
But as long as you don't know whether or not you can get away with it, telling the truth is always the best policy. And so we have a bunch of these policies that we've developed over the millennia, which are good principles.
Mm.
Treat people nicely, don't steal, all that kind of stuff. Because as long as you don't know everything, these are stable and good strategies.
Yeah.
And so now we have an AI that might be able to come up with other strategies. We need to be open to the idea that, maybe we need to do taxes differently, or we need to collaborate differently, or whatnot.
Mm. All right. So on terms of the creative shift, like how the whole creative industry is now thinking about all this content being able to generate by Dolly or the large language models and so on, Hollywood seems to be like, oh shit, they're gonna use our intellectual property now. They can create their own Superman thing. Um, I think that this has already been played out once in the music industry.
Mm.
So and the main thing. So what are the things they can do? Yeah, they can hunt down the people who use their intellectual property, or they can build something that is like useful in terms of like licensing. I mean, what's the name of the company that does the big one? Epidemic Sound.
Mm-hmm.
So they're doing licensing. You can use their stuff if you have the license. But then also it comes down to the challenge of distribution. Like who can actually monetize it. And building a good distribution thing is hard and takes a lot of effort. And I think it's going to be hard. People are not going to want to build that distribution that makes the value come back to the company who created something if it's at risk of being sued for somebody.
Mm-hmm.
But then I think what is going to happen is, like these people are saying like, oh, there will be no more Citizen Kanes or, like these great art pieces produced in this AI economy. It's like, okay, so to me, that's just one more guy saying like, oh, trying, like I want to protect my business model. I want to maintain the status quo. And basically what people have to accept is that the art is going to be different. It's not going to be the same art. The same kind of movies or the same kind of stories are not going to be as valuable or perceived as valuable in the future. Let's say CGI effects and stuff like that is not going to be the selling point in, like, let's say 5 years from now, because it's very easy to do compared to what it was. So before you could have like a movie, now we have this super cool rendered effects. Yeah, I can do that too. There's nothing special anymore. So I think, like the arguments that are using are also wrong, because it will allow us to focus on more fundamental, like good questions, good storytelling, because the production is what's getting more efficient. Not that so we will have more time to focus on great ideas. And yeah, I'm just thinking this like, oh no, we need to take it easy is just not the right approach for people to, like get into that camp. We need to be pro having new things being explored, as always, I would say.
Well, I think two things are often conflated in these articles and threads, which is the process of creating art itself and the business model.
Yeah.
Nothing is being taken away from the artists. And the things that are being taken away, I guess nothing's being taken away.
Yeah, yeah,
I mean,
yeah.
the thing is, um, what you have as an artist is the satisfaction of creating something.
Mm-hmm.
And the fact that we can take photographs today
Mm.
doesn't take away from your potential satisfaction of trying to draw something as realistically as possible.
Yeah.
So that's not really being taken away. What is being taken away is something that doesn't have to do with art itself. And I think when people make these articles, they're conflating the two. What's being taken away is your ability to charge somebody else money for your service.
Yeah.
So what you can offer of value to somebody else as a service is completely different from what you have or are doing as an artist.
Mm.
Like if you want somebody to create a storyboard for you,
Mm-hmm.
but Midjourney and ChatGPT can do that instantly, it's very hard to rationalize that you charge money for that unless yours is far superior to it. Now, what does that mean about you spending your weekends doing that if you enjoy writing storyboards?
Mm-hmm.
Nothing, really. I mean, the example I always give is the fact that there are some footballers out there that are really good, much better than you at playing football. Does that mean you don't want to play football anymore?
Mm.
No. Does it mean that you can't charge money for playing football? Yeah, probably. You know, you have to be really good to make money playing football nowadays.
Yeah.
And it's the same thing with AI now. But here's the thing, like the people that are very much against this are laggards in the industry that are trying to protect, exactly like you said, a certain business model.
Mm.
So the original record labels, what they had was distribution.
Mm.
Every artist wanted to get their CD or tape or vinyl in the hands of people,
Yeah.
and that wasn't possible as an individual before.
Mm.
Now, the cloud is such an amazing thing. A little startup company can compete with a retailer that's international,
Yeah.
instantly, and you can't bemoan that because it's an advantage to the consumer.
Yeah.
The
Exactly.
fact that every consumer can now trivially access every song ever made,
Yeah. Mm.
with Spotify is
Yeah.
amazing for the
Yeah.
consumers. So, the tiniest violin in the world is playing for the record labels that are sad that their exclusivity over distribution channels
Mm.
is not the same today. Um, it's the same thing with what AI can do. It's going to be a very small violin for people that are like, well, I used to be able to charge for my realistic hand-drawn portraits.
Yeah.
All right, it's time to move on because now all the people that have access to hand-drawn portraits now, they're the ones that have won from this transformation.
Mm.
So it's not really. I mean, I have a hard time feeling sorry for them.
Yeah. I mean, yeah. I guess I can feel sorry for them, but it's like this is just the way the world has always worked. Like something new comes along and you have to change and you have to update your business model. You have to pivot. Maybe you have to like start a new company or learn a new skill. It's just that's just how things work. But in this like this cultural shift that is happening now, there's actually a super good series called the Playlist on Netflix, which is basically portraying the whole battle between Pirate Bay and the record labels, and how Spotify basically came along and say like, well, we have a more convenient way of actually delivering what the customer needs to them. And so now we're just gonna like the whole music industry went like belly up. And this, I think, if somebody wants to sort of cultivate or get some input on like what is to come, this is sort of a good thing to check out, because similar things are definitely coming down the line.
I think what they did was they really hit the head on the nail with value. Um, I'm passionate about AI and I want to do a lot of engineering work, but what I end up doing most of the time is helping customers put a number on customer value. They are all too often extremely out of touch with what customers really value and what they're willing to pay for ultimately.
Yeah.
And to give Apple credit, we used to joke when I was at Microsoft that Microsoft, if they're going to sell grass, they would give you a long list of how genetically modified it is, how resilient it is to certain chemicals, and this
Focus
and that.
on the specs.
Yeah. Whereas Apple would sell you a dream. Imagine a green field of grass and you running barefoot through it. They wouldn't even mention the seeds. They
No.
would sell you a vision.
Yeah.
And so, I mean, they understand what it is that the customer values, which is not the spec or they're buying
The experience.
an experience.
Yeah.
Yeah. And it's the same thing with music here. Customers don't value distribution. So the fact that you can't charge for distribution anymore, or let's say they do value distribution. The part of distribution that they value is being able to get it right now, this second.
Yeah. The
That's
user
what they want to pay
experience
for.
is the thing that they value in the distribution.
I mean, you need to question everything. Do users value curation? Maybe. Playlists.
Mhm.
Yeah, Spotify's putting an effort into playlists. Do they value original content curated by the curators? Maybe, maybe not. But I mean, these are the conversations that you have to have. I mean, everybody knows this stuff: price sensitivity, market fit, all that kind of stuff. But for some reason, a lot of times it's we run past that because that's the boring part. But that's how you guarantee that your business is viable.
Yeah, but most people just come from the point, and I've done this mistake a lot of times myself. It's just like, what do I want to do? Like, I would really like to build this kind of thing, or like to do that. It's like, okay, and then you're sort of letting that drive your work for a time, and then you basically start realizing, but nah, this is actually what I want.
Yeah,
it's not what the market is demanding.
Yeah,
or what the customer might like enjoy.
Yeah,
there's this interesting story about from a guy named Rory Sutherland. It's a marketing guy at Ogilvy. He was basically saying, like, okay, how can we running the railway make us more competitive towards the airlines? So do we need to make faster trains? How much is that going to cost? Okay, super much. It's really expensive. So what they did was they focused on making the journey, let's say, twice or three times much as enjoyable.
Yeah.
Just like, okay, better seats, better table, Wi-Fi, like a good bar.
Yeah.
For this price, you could that it would take to get the journey down like 20% in speed.
Yeah.
You could hire supermodels to come and serve and give out pillows.
But that's a beautiful meta-analysis. Why do people want airplanes to be fast? It's because the journey itself is a horrible experience.
Yeah.
Standing in those stupid security lines, nobody wants to do that. So the faster it's over, the better. But if it wasn't such a horrible experience, maybe the time isn't right. Video games are really good at that because there you have, for example, a trade-off between, let's say, being super realistic or being fun. Like a driving simulation game is actually really boring to play for almost everybody except for real gearheads. So, Forza Horizon on the Xbox, the point is for it to be fun. I mean, the game developers know what it is that the customer wants, and that's what they're tuning for. They're not sitting there trying to make the physics simulation as realistic as possible, or, I mean, they might be, as long as it furthers the funness of the game.
Yeah. But also some things you have to do just because it's hard, because you're learning from that. And usually there are, like something hard to do that is also valuable. But the learning experience, well, I sort of lost my thread here. So what more do we have? Yeah. So you told me that you were working on some descriptions or ways to explain multiple dimensions. And I basically went online to see what are the arguments, like how do they structure it, like what are the good explanations for different dimensions, and I came across this little thing. I tried to take some notes of like, how do I understand it? So basically, like dimension 0 just being 1 point, first dimension being a line, and the second dimension being like 2 lines crossing. And then even at the third dimension, I think things started becoming a little bit unintuitive, because what they said was, okay, so the higher dimension and the third level dimension is something that will be able to take you from point A to point B in the second dimension, like, like skipping over it. I sort of like, I could get the other parts, but I already started like, okay, here's something that is weird
Yeah.
starting to happening, and I can, intuitively understand the third dimension, but then when you try to explain it, what's actually happening, it gets a lot more complicated. So
Yeah.
uh, the reason why we just started this conversation is because you're working on a book. You
Hmm.
spend some time writing,
Yeah.
and maybe you want to tell us a little bit about what you're working on and why you're doing it. Like, why do you dedicate yourself to writing in the first place? What does it give you?
Writing is very therapeutic. It's fun to write,
Mm-hmm.
like it's fun to write music.
Yeah.
Um, I guess this book for me has been about non-duality,
Mm-hmm.
meaning a lot of times there's two different ways to look at something.
Mm-hmm.
And I think uh, the best way to approach things is not to decide beforehand which way to look at things,
Yeah.
but rather absorb it as it is,
Mm.
in a manner of speaking. And
Yeah.
there are sort of philosophical movements around non-duality, and I try to present everything through this lens. So I start with philosophy and math, and then go into physics and biology and society, and then back to philosophy. Also showing something that I feel like I've learned in my life. In school they always make it seem like there's basic math and then there's advanced math, and you can sort of build it upward like a pyramid.
Mm-hmm.
But that's not really how the way math works in mathematics. Mathematics is like a graph, and there's no one mathematics that stands above another. They're all sort of pointing at each other from different directions. So
Mm-hmm.
geometry and algebra and formal systems and computation, they're all just different ways of looking at the same stuff.
Mm-hmm.
So that, yeah. And the same thing for me with philosophy, physics, society. They're not like you build them upwards. They're all looking at a lot of the same things from different angles. So that's what this book is about, in so far as I can capture
Yeah.
it in words.
Mm-hmm.
But I really like the idea of taking as simple as examples as I can to explain something um, that shows this non-duality principle. So dimensions is a really cool uh, a cool mathematical concept that can be very unintuitive even in simple cases.
Yeah.
And this is also an argument against the idea that we humans are these infinitely capable abstract thought machines, where, as you said, even low dimensional geometric things are not necessarily especially intuitive to us.
Yeah. I mean, the thing is, like, for me, when I read about this, like, I think it was 10 dimensions in this, and there's, like, hypothesis for there being more,
Mm,
but it's like the explanation and how I perceive it
mm.
doesn't really have much to do with each other.
Okay, so I have the best example for how to explain dimensions. And by best, I simply mean my favorite.
Yeah.
Uh, Everything has a good music analogy in my
Okay.
mind. So let's
Here
go
we
with the
go
music
again.
analogy. Let's start with very low dimensions.
Hmm.
Really, the best way to think of dimensions is, to use a technical term, degrees of freedom.
Hmm.
So how free is this number to move?
Yeah.
Okay, so imagine you have a little dial,
Mm.
and the dial outputs a number. The number is the volume in your speakers.
Hmm.
And you turn up the dial, and the volume goes up. And in fact, it responds exactly to how much you turn.
Hmm.
So we're talking about a one-dimensional thing here.
Yeah.
You have one dial
Yeah.
and one output.
Yeah.
And so if you have it on 1, the volume is 1. And if you screw it to 10, the volume is 10.
Yeah.
How much freedom does it have? It has 1 degree of freedom because it's correlated 1-to-1, the volume that comes out, with how much you turn the dial.
Yeah.
Now, imagine you put on a compressor. You know what a compressor is, but for those listening, a compressor is basically something that puts a little bit of a cap on how much volume comes out of your speakers. So For the first 5 ticks, 1, 2, 3, 4, 5, the volume goes up, and then it hits a threshold. And then in order for you to raise it one more tick, you need to turn the dial 2 steps. So instead of going from 1 to 10, it goes from 1 to 7.5, because once you get to 5, you need to screw so much more in order for that volume to go up. So now that you have this compressor on, the volume is not really able to go up all the way. So here's the question: how much freedom do you have? Not as much as you had before, right? Because before you had the ability to move it one to one.
Yeah.
What has happened? Well, you could say that you've added an extra dimension. So imagine instead of the volume going from 0 to 10, it goes from 0 to 5, and then it rotates to the right instead. So it's actually still going from 1 to 10, but instead of going from 1 to 10 upwards, it's going from 1 to 5, and then it starts rotating to the side. So it still goes from 1 to 10, just not in volume. It goes in another imaginary.
Yeah, it's moving sort of towards the same position, but in a slightly different angle.
A slightly different angle. So it can still be 10 volumes long, but the output's not going to be 10 in total. Does that make sense?
Yeah, it makes sense.
That what I just explained to you now is imaginary numbers.
Yeah.
It's two-dimensional numbers where the volume, it doesn't actually go into an imaginary direction.
No.
It's just compressed. But the fact that you are not as free in this direction means that your freedom has to be either in another direction or something like that. So you can have fractional dimensions. You can have 1.5 dimensions, or you can have 2 dimensions, or you can have 3 dimensions. Now, what makes higher dimensions weird is, you can imagine going up and down 10 steps and right and left 10 steps and that kind of stuff. What's weird is, and unintuitive, is that your sense of distance does not extend to higher dimensions. So how far do you have to turn the screw in order to reach 10 if you have the compressor? Well, if you think really hard about it, you could probably figure out that you need to screw it to 10 to get the volume to get to 7.5 or something like that. And we're only talking about 2 dimensions. When you add 3 dimensions or 4 dimensions, having that intuition for how far things go becomes really difficult. Let me give you one example. A planet orbiting a star. You can have an intuition for exactly how much you have to pull on that planet for it to stay in a stable orbit around the star. Let's say you add a 4th dimension. How much pull do you have to do for that orbit to stay stable is extremely difficult to calculate compared to 3 dimensions. So that's the main thing about high dimensionality that makes it really difficult for us to extend our intuitions into higher dimensions.
But from reading these things, it's like basically what it seems to me is like, okay, you try to classify things into dimensions basically to serve some kind of concept. It's like you want to explain, where does this thing actually, where is this? Okay, so is it in the idea? Is in the concept of our ideas? Is it like in relationship to us physically? It's like a methodology to categorize different frameworks.
I think it's best to think of dimensions as, how much am I allowed to change this number, really? If let me give you another example of something that looks 2-dimensional but is actually 1-dimensional. Let's pretend, for the sake of argument, that the price of a house is 100% correlated with how many square meters the house is. So you have 2 variables: 1, the price of the house, and 2, the number of square meters. This looks like you have 2 numbers that you can change, but I just said it always has to be a 1-to-1 correlation. So if it's 100 square meters, it's $1 million. If it's 200 square meters, it's $2 million. There's nothing around there. You can't have a 5 square meter house that costs $100 million. That doesn't exist. So you have 2 numbers. how much freedom do you actually have? You only have 1 degree of freedom, because if you double the number of square meters, you double the price necessarily. So it looks like you have 2 things that you can adjust, but you can't.
Yeah.
Because if you adjust one, you adjust the other. So it looks like it's 2-dimensional, but it's actually just 1-dimensional.
Okay, so I mean, then this is basically most valuable. I mean, how people use dimensions is basically in the realm of physics. You have some property you want to relate to a concept.
I think the house example is in data science, we use the term vectors. A
Yeah.
vector is basically just an arrow in some number of dimensions.
Mm-hmm.
So let's say you have an arrow pointing at the house price.
Yeah.
This arrow can only point across, on a line. So it's
Yeah.
a 1-dimensional arrow, even if you have the number of square meters and the house price.
Yeah, and then you add a second dimension, which another dimension, and say like, okay, population density or something like, okay, so median income,
Yeah.
and these things, and
Yeah.
they basically become. But this is what I mean. So these are okay. So you call vectors in this case, but that's very similar to me to what I look at these physics examples, and it's like, okay, so this is dimension. And you can sort of use this language to prescribe, okay, so this exists in the realm of ideas,
Yeah.
or this exists in the realm of physics. It's like these are different dimensions of explaining and positioning concepts around.
Are you
this.
asking what a dimension is in and of itself?
Yeah, I guess,
because
like,
that
what
I
is
think
the usual?
that's very much like asking what is a number in and of itself. It's a very
But it's a tool to use to get somewhere.
yeah. I think it's a good description of what you're allowed to do with certain magnitudes.
Yeah, and in different fields, you call it this kind of way of thinking as a dimension or a vector or whatever it might be. Because like when you come to like the 6th or the 7th dimension, it starts to be like, okay, now we're in the realm of possible timelines and these kind of things, and it's like, okay, so now we're just using the dimension number 7 as it builds on dimension number 6 to explain a different thought experiment of how things can relate to each other.
Let's clarify one thing.
Yeah.
Dimensions don't have a hierarchy. It's not like one dimension is on top of another dimension. They're, by definition, actually orthogonal, or they, I was going to say they're orthogonal to each other, but they're basically independent. Otherwise, they wouldn't be separate dimensions. So if we just talk about the physics stuff for an example, consider the magnetic field. The magnetic field has polarity. It can either be north or south. It can't be north, south, or east, like the compass on Earth. It's only 2 polarities, which means, for the sake of argument there, you only have a certain amount of freedom in terms of what polarity you can have. Temperature is another example. You can go up and down on the temperature scale, but you can't go sideways on the temperature scale. So what physicists mean when they talk about dimensions in addition to our space and time dimensions is what freedom do particles have in terms of movement and other properties that you can give a number to. So, for example, you can say this particle is at point number 5 on the x axis, point number 2 on the y axis, blah blah blah, and in the 3D, you can say it's at this point in space. I mean in time. So that would be the 4th dimension, maybe. And then you have a number of other dimensions where you would put a number. And depending on what the number is in those dimensions, different things happen to the particle. And the thing is, you can move that number up and down in those other dimensions, and things will happen differently to the particle depending on where you are in that number. So obviously, if I were to come and give you a pat on the back, but on the time dimension, you would be somewhere else, I would not be able to pat you on the back because you'd be gone. And it's the same thing with those higher dimensions. Depending on where the particle is in those dimensions, they do different things, interact with each other differently, and that kind of stuff.
So basically, it ties down So what physicists mean when they're outlining these different dimensions is like something that is useful in terms of describing something like the double slit experiment.
Yeah, for the double slit experiment, or maybe you can think of it as a video game. Your
Mm-hmm.
character has a number of numbers that describe it,
Mm-hmm.
where it is in space, how much HP the character has left, and blah blah blah.
Mm-hmm.
Those are basically dimensions.
Yeah. All right.
It's weird to think of HP as a dimension.
Yeah, but it is.
It is.
Yeah, but it's a very potent dimension,
Yes.
especially for us humans.
And it is funny to think about things that feel so intuitive to us, but really have no bearing on measurements and stuff. For example, causality.
Mm-hmm.
There's a very strong correlation with how many birthdays you've celebrated and how old you are. And so if you stop celebrating your birthday, you won't age anymore. Obviously, that's not true. But it feels intuitive to us that things that are 100% correlated might also be causal with each other and stuff like that. So,
but I want to go back a little bit and get your thoughts on like why. So you're writing this book, and like what why do you think that the process of writing is actually valuable? What do you think you're getting out of this? It's like there's two things I'm thinking about. It's like criticizing your previous thinking is one of the values that I think come out of writing, and then uh, the whole creative process of like starting something complex, and then in the beginning you basically don't know what it's going to turn into, and and I guess at some point you didn't really actually know what this book was going to
yeah.
be.
But that is
And
also the theme of the book itself,
yeah.
which is to is it possible to observe something without as it is
Mm,
without interpreting it?
mm.
That's sort of what I want to reach at. So it sort of makes sense to start writing the book without knowing exactly what it's about.
Yeah, it's because as an artist, like whenever I started writing a new song or a new riff or something, I thought I had an idea of what it was going to be, but that changed very rapidly as soon as I started working on it.
Yeah.
And the process of writing is very similar. You very quickly start seeing your the opportunities, let's say, for expressing things in different ways. And that's like for me what is the most interesting part in doing any kind of work, I would say, because it's very similar to art. I don't really know like where to draw the line on what art is, in terms of like just living as a piece of art.
I think that there's two interesting things here. One is my personal belief is that art is just what artists think is fun.
Yeah,
And
yeah.
so
What
that
is
means
art? Yeah.
everything is included. The second thing is what role does the consumer of art have in the process of you as a creator creating the art piece? For example, does a consumer need to understand your intent with a piece of art in order to consume it correctly, and so on? And I think that there's two ways of consuming art. One is based on how you perceive it, and one is maybe as it's complemented by understanding your thought process as you created it. And I don't think that it's one way or the other, because some artists intentionally
Yeah.
leave it
There's a
abstract.
goal.
Yeah. But I saw a movie recently that I liked a lot called The Whale
Mm-hmm.
with Brendan Fraser. And man, tremendous actors, the whole bunch in that movie. And I actually don't know a lot about the background of the movie. I know it's a play. And as I was watching it, the people displayed such complex behaviors. I was trying to figure out what's the point? Like, what are they trying to tell us? Because a lot of movies that you watch have a lesson at the end. And therefore, family comes first, and therefore, you shouldn't do this. But this movie left me feeling unsure about what did we see here. And I really like that because I think it was just an exposition of extreme human behavior.
Mm.
Uh, it really appealed to me because it left me feeling uneasy, sort of like progressive jazz can leave you feeling unsure of where is this music even going. And what you do, instead of being narcissistic and being like, I knew the breakdown was going to come there, you just sort of enjoy being dragged along
Yeah.
this journey where the music doesn't tell you where it's going, and you just, you know, enjoy it piece by piece. And that's sort of what the book is to me. It's supposed to be an exposition of how much can we look at something without having decided beforehand what it is we're looking at.
Hmm. Yeah. All right. I think that's wrap for today.
Sweet. See you around.